The general shapes of small molecules can be predicted based on the arrangement of groups of electrons around the central atom. This is based on the principle that electron groups repel one another and will arrange themselves in such a way as to minimize this repulsion. This is called the valence shell electron pair repulsion theory, or the Vesper model. The groups of electrons are called charge clouds in this book. Other terms for charge clouds include electron pair domain and electron groups. I'll kind of bounce back and forth. I'll try to use charge cloud, but I've taught this out of a lot of books, so the other terms will slip in every now and then. The first step in the Vesper model is to draw the Lewis structure and count the number of charge clouds surrounding the central atom, or the atom of interest in a molecule with multiple central atoms. Charge clouds are groups of electrons, not individual electron pairs. One lone pair of electrons, one single bond, one double bond, or one triple bond all can count as one individual charge cloud. The second step in the Vesper model is to use the number of charge clouds to predict the arrangement of them. To minimize repulsion, we want electron groups to be as far apart as possible. However, Vesper balances that by considering their distance from the central atom. The resulting arrangement of charge clouds is called the geometric arrangement. Other names for this are electron group arrangement or just plain old geometry. Again, I'll try to stick with geometric arrangement, but if I say something that confuses you, just let me know because I've taught this out of several different books. The geometric arrangement does not account for whether a charge cloud is a bonding or a non-bonding group of electrons. It looks only at the number of charge clouds around the central atom. We'll look at the different geometric arrangements on the next slide. This is a really, 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 really important table. You should put it on your crib sheet, but it's one of those things that you need to gain enough familiarity with not to have to consult it for each structure. In class, we will cover slides 8 through 13 in this chapter, and they provide details on each geometric arrangement. You should be aware that I'll cover this material largely by showing molecular models, so I won't be writing a lot on these slides as I go. You'll need to be diligent in making sure you're taking notes while I'm talking, but you also can get a jump start by using this table to pre-fill some of the blanks in slides 8 through 13.